effects of radiation on life. Radiation is not good for biological systems. You can have acute radiation damage, or you can have chronic radiation damage. Acute radiation damage is when you've got a large exposure and in a short amount of time. And so this typically happens when we set off nuclear bombs, or when we have nuclear reactor accidents like Chernobyl and Fukushima. In these situations, a large number of cells die. And especially the cells in the immune system and in your intestinal lining are affected. It's the cells that are rapidly dividing that are affected the most by acute radiation damage. And so symptoms include a weakened immune system and an inability to absorb nutrients.
Is that what we use for chemo then? Okay.
Well, chemo is also attacking rapidly dividing cells, but it's not radiation. They do use radiation also. So, like this says, mild cases, recovery is possible, but usually death would occur as a result of infection. So the radiation itself doesn't kill you, but it knocks your immune system out so that something else comes along and kills you. And on top of that, you're not able to absorb nutrients very well, so you're malnourished. So, bad news. Lower doses over long periods can also cause problems. And it's believed that this can increase the risk of cancer. As it says down here, cancer risk increases with increasing radiation exposure, but the exact threshold for that increased risk cannot be determined. Nobody's volunteering to participate in studies here. It's hard to get the data. So radiation can damage your DNA. Your DNA is replicating, and the success of your staying alive depends in large part on your DNA replicating correctly, right? You need accurate copies of your DNA, because just some little mistakes can cause things to really go haywire. Well, radiation can damage the DNA and cause the new DNA to be damaged. So affected cells would normally be killed, but some cells may survive and then grow abnormally, and those are what becomes the cancer. Radiation exposure can cause genetic defects. So if the DNA in eggs or sperm are damaged, then the offspring could have genetic abnormalities. So what's really interesting here is that genetic defects like this have been observed in laboratory animals, but they have not been verified in humans, not even in studies of the Hiroshima survivors. I mean, the people that survived that got huge radiation doses, right? And studying their descendants, there's no verified evidence of genetic defects from that. It's still just not a good idea to be overexposed to radiation. We talked about how to detect radiation, Geiger counter and dosimeters and stuff. When we're talking about measuring your exposure, we're talking about the number of decay events to which a person is exposed. So, a uranium nuclide decaying into another nuclide and giving off alpha particles or whatever, that would be one decay event. The unit that's used is the Curie, after Madame Curie. That is equal to 3.7 times 10 to the 10th decay events per second. So that's a unit, but unfortunately, it's not really very effective in telling us how much biological damage would be done, because different types of radiation produce different effects. We talked about the semi-truck and the four-door sedan and the motorbike, right? And so some of those, the alpha particle, if it's outside your skin, not going to cause much damage at all, but then if you ingest it, it's going to be really bad. So a better way to measure radiation dose is looking at the amount of energy that's actually absorbed by body tissue. And so 2 units here are the gray, which is 1 joule per kilogram of body tissue, or the rad, which is 0.01 joules per kilogram body tissue. And rad stands for radiation absorbed dose. So we can measure the energy absorbed, but it still doesn't account for amount of damage, because the gamma rays have low ionization density, alpha rays have high ionization densities, and we got the differences in penetrating power. So there's also the biological effectiveness factor, or RBE, standing for relative biological effectiveness, and that's a correction factor that would be multiplied by the dose in rads to get like a corrected value. And so that would be in REMS. REMS stands for Röntgen equivalent man. So your dose in rads times RBE is your dose in REMS. So this is going to, this RBE is going to take into account what kind of radiation you were exposed to. So it's going to be a higher number for alpha radiation than for gamma radiation. This is a table that's kind of interesting. Radiation dose by source for persons living in the United States. So we've got natural radiation. A 5-hour jet airplane ride is going to get you 2.5 millirems for each trip. Cosmic radiation from outer space, yes, that is real, and no, a tinfoil hat is not going to help. Terrestrial radiation, there are radioactive substances in the earth, and they're just, sending up radiation. There are radioactive nuclides in your body, right? Remember carbon-14 dating? Some of the carbon dioxide has carbon-14 in it, right? And so when we eat things, there's carbon there, and we're going to be consuming carbon-14. So, it's just everywhere. Radon gas is another one, and that leaks into basements. I think I mentioned that before. 200 millirems per year, and that would be your lung dose. And so you can see that one's significantly higher than these other ones. Diagnostic medical procedures. So, X-rays are good because they can help find cavities in your teeth or broken bones or other problems, but we don't want to just go willy-nilly having X-rays because it also exposes you to radiation. So there's a balance that's needed there. Mammograms also have radiation. Some other things, a barium enema. So this is where they can look at what's going on in your digestive tract. By putting barium in there, and then they can take an X-ray of it, and they can see where it's going and what it's doing in there. And so here, the radiation dose is due to the X-ray part. Thallium heart scan, CT scans, those are going to involve a radiation exposure. Consumer products, building materials, luminous watches, tobacco products. Look at this. Smokers of 30 cigarettes per day, 16,000 millirems per year. That's a lot. It's a lot compared to all these other things, right? The luminous watches, they're not a significant exposure anymore, but they used to use radium paint. And there were ladies that painted the dials of these with the radium paint, and they would lick the brush to get it wet so it would have a nice point. They didn't know that, yeah, it's not good. They didn't make it.
Where does the radiation come from when you smoke?
That's a good question. That's a very good question. Off the top of my head, I don't know.
Isn't it in the chemicals in the cigarette?
Yeah, I mean, obviously it has to be in the tobacco product somehow. And I don't, the process of smoking, where you're inhaling the combustion products into your lungs, that's going to cause a lot more damage, especially from alpha particles, because now you're getting them into your lungs instead of them being outside your body. But I don't know exactly what's in the tobacco that causes that.
There was a guy who made a nuclear reactor in his backyard using radium paint.
Yeah? Did he blow himself up?
No, he actually survived for a while.
Sounds like a fun project.
Yeah, radiation is just, not the safest thing to mess around with.
Sounds like he had fun.
So, those exposure doses we were just looking at, those are not going to cause significant health effects. Those doses were all in millirems. So these are the doses that will cause problems, and these are in rems. So this is 1,000 times larger. 20 to 100 decreased white blood cell count. 100 to 400, this is where you get radiation sickness. That can include vomiting and diarrhea. That's the intestinal lining cells being messed up. Skin lesions, increased cancer risk. Really high doses, 500, 1,000, 2,000. Death often within 2 months, 2 weeks, or within hours.